Hello everybody. Today we will be doing a single displacement reaction of hydrochloric acid, zinc, and will form hydrogen gas and zinc chloride.
Alright, we're going to start off by grabbing a 150 milliliter Erlenmeyer flask from the shelf to contain our reaction. We're then going to add our hydrochloric acid to the flask. That's 15 milliliters of a 6 molar solution. Alright, we want this reaction to take place in a closed environment, so we're going to seal up the Erlenmeyer flask. Now we're going to take a thermometer and pressure gauge from the instruments shelf in order to track temperature change and pressure created from evolved hydrogen gas. Okay, we are now going to start the reaction by adding 0.25 grams of solid zinc from the materials shelf. As soon as this is added, you will start to see bubbles of hydrogen gas forming from the surface of the solution. You'll also see a pressure increase as a result of this gas and a temperature increase resulting from the energy released in the reaction.
So a single displacement reaction is a type of oxidation-reduction reaction where an ion moves out of a compound and is replaced by another, more reactive element. In this reaction, using a reactivity series, we can determine that the most reactive element is zinc, so the zinc will displace the less reactive H+ ion. This reaction will form a new compound, zinc chloride, and the hydrogen will combine to form hydrogen gas.
And we are going to wait until it cools down to room temperature.
Alright, the solution has now cooled to within 0.5 degrees of room temperature. So we are going to want to use a syringe from the instrument shelf to measure the hydrogen gas produced. Alright, mousing over the syringe, it looks like this reaction produced 92.4 milliliters of hydrogen gas. At this point, you can now record all the data you've collected and also do your calculations to find out how much zinc chloride has been produced compared to the theoretical amounts. Okay, that will conclude our experiment. Thank you for watching.